Hello, everybody, and welcome to Industrial Automation. It doesn't have to. In case you're new to the program, I'm Brandon Ellis. I'm your host and also the owner of elliTek. As we jump into the episode for today, I want to ask that you hit that follow button and subscribe button based upon the platform that you're listening on. And if you're listening specifically on Apple Podcasts and Spotify, and you enjoy what you hear today, leave us a 5-star rating and review. We sure would appreciate it. Now that we've got the marketing out of the way, I just want to say thanks for tuning in. So, let's get started. And hey everybody, this is Brandon Ellis. Welcome to Industrial Automation It Doesn't Have to, our fantastic, fabulous podcast. And with me is Miss Beth Elliott. Hey, Beth.
Hey, Brandon. I'm glad you got that right this time.
Yeah, I've not gotten that right a couple of times, so for sure, I'm going to hold my paper up here so I can read it. I got new glasses.
Oh, they looked very nice.
Yeah,
I'm sorry I didn't notice.
It's progressive lenses, but I've been on progressives for years now. But when you change prescription, it just seems so difficult to get it right.
Yeah, oh, I know.
And sometimes I feel like I'm the one that's being, pesky, but
you're the one living in your eyes.
I gotta find it. Yeah, so I'm gonna have to hold my piece of paper right now. But anyway, welcome to Industrial Automation. It doesn't have to. Today we're talking about some practical automation alternatives that may not be obvious.
Okay.
So I'm glad everybody's joined us today. It's going to be an interesting topic, kind of sort of similar to a few of the podcasts are in the same guild, if you will, of the podcast, some 2 or 3 podcasts we've done in the past, but just different automation alternatives that may not be obvious. So that's what we're going to be talking about today. But first, what's been going on, Beth?
Well, I'm looking forward to the PLC course that's coming up.
I'm so excited about that PLC course. I've been, if you're connected to me or follow me on LinkedIn, Brandon. What is my LinkedIn? I don't know.
Brandon Ellis.
Brandon Ellis, at Brandon Ellis. Feel free to send me a connect if you'd like to connect, an invitation. But that PLC course, the curriculum, was authored by moi.
It looks very good.
Yeah, and so I've been working on this for a while. I'm pretty excited about it because we don't often get into. We talk about industrial automation, and I mentioned ladder logic, and I've talked about ladder logic before. That's what you program. It's a symbolic programming code for 99% of all the automation equipment on the earth uses a PLC, a programmable logic controller. But most people that offer classes, usually it's the manufacturers, jump you straight into, welcome to PLC programming. And a lot of people begin lost.
Well, you got to have a basics. You got to have the foundation, right?
You got to kind of intro into that. And so we go into how did ladder logic come to be and what it was originally based upon. And the answer is schematics. And so that's what we utilize in this curriculum. So it's a lot of hands-on. It's not a lot of popping keys on a keyboard until we get to the end. Okay. But it's a day-long training, and we're kicking up our first class in June, and then classes will start, I guess, once a month, and they'll be added to the training calendar.
Exactly. And so if you're interested in learning more, you can go to ellitek.com/technical-training, and the courses will be there.
Technical-training, that's the same as technical-training.
Oh, my apologies.
So, all right. So let's keep rolling.
Okay. Yes.
So the other thing is, of course, that welcome to summertime, everybody. If you're in the southeastern United States, or even I was talking to somebody in Michigan, and they said it's summertime here as well. So we've gone from we had a week of spring.
Oh, it was longer than that.
Was it?
Yes.
I don't remember. It seemed like it went away fast. But now we're starting to get into the balmy days of summer here in the good old southeastern U.S. where humidity is king. Mm-hmm. And so it'll be good. But, just a few months ago we were freezing and wishing for warm weather. And I think I said it then, here in just a couple of months we'll be wishing for cooler weather and wishing for the fall. So, can't have one without the other.
No. And you got to enjoy it while you can.
So let's get on to our topic.
Yes.
The title, please. What's the title? Which one?
And today's title is Industrial. Okay, we'll
Yeah,
wait
well,
till
that's
that.
applause. Okay, so
Industrial automation. It doesn't have to be obvious.
all right, that works. So it's been a while. It's been a minute since I've done my sound effects, and I changed them up last time.
And we
now
still haven't labeled
I
them.
still haven't labeled them. So it makes it for a fun guess. So yes, industrial automation doesn't have to be obvious. And so I mentioned that we were going to be talking about some practical automation alternatives that aren't necessarily obvious.
But before we get into that, I think we need to address some things that are going on in the world today.
Again,
Just to highlight just a little bit, just because we don't have our heads in the sand.
warning, there are no differences, but let's review them because unfortunately there's not very many differences.
This is why we have to do why it's not obvious, because
Yeah, and I'll tell you why. And of course, I get to look ahead, guys, because I see the outline and the research that Beth has done. But a lot of people say why, still are asking why. Why are we having such long lead times? Why are, really, you mentioned, Brandon, in your podcast about why is there a semiconductor shortage? And we were talking more about why it takes so long to replace or replenish those semiconductors, because you have to grow a semiconductor. It's a crystal. It has to grow its crystalline structure. And so that takes time. Just so you know, anywhere between 1 week to 3 months, according to the type of crystalline structure and substrate that you're growing. So it's not a let's ramp up production kind of situation, because you just can only do that by creating more molten crystal bath machines to draw these things out. So it's not an easy thing to just make more, because everything grows at a rate. But they've asked, okay, still, but why? Why are we hearing all this stuff? Why are we seeing the price increases, across the board? Some of that's fuel costs. Why are we seeing the inflation and that kind of thing? And so that's where we can start, is some of the whys to that.
okay.
So your research takes us to some of that.
Oh, okay. Yeah, we did talk about the semiconductor, but the war in Ukraine. So Ukraine is a leading supplier of neon gas, and neon gas is used in semiconductor production.
Bing, ding, ding.
And a major manufacturer of copper wiring harnesses used in vehicles.
Okay, so one of the big shortages, and I don't remember which podcast it was, but we talked a bit about a resin shortage. Resin equals plastics. And that's why we were thinking, and we are in the throes of a plastics shortage. But that's also because, and I don't think you have that in your notes, but China has been undergoing lockdowns for the past month and a half, and a lot of plastic parts come from, we source those, the world sources those from China. And so you remember in 2020, March 2020, here in the good old US of A, we were all, for the most part, locked down. And so production of a lot of things just ceased for that month. If you're not sure what that looks like, go to the Dow Jones National Average and scroll back to March 2020, and you'll see a big stop. Everything just stopped during that month. And so it's because nobody's producing. Well, that's where China has been for the last month and a half. And so they're not producing those things. But to your point about the copper wiring harnesses and the neon gas for those kind of wiring harnesses, cables of different types are now a big pain point for shortages. So we're able to deliver servo motors, drives, amplifiers for the most part, although we have to look for that. Sometimes we have to make substitutions and things of that nature, but it's the cables, the encoder cables and the power cables that are suddenly, and even sensor cables outside of motion where we're using sensors, those are the shortages we're starting to see now. Oh. And so people say, why? Well, the war in Ukraine does have a role to play in that, because of the sanctions. They're keeping a lot of people from purchasing things, or they're opting, if they're a cool company whatsoever, they're going to opt to not do business with Russia during this time, just as a kind of making a statement. But for whatever reason, either through sanctions or because they just don't want to, You got to have neon gas, and
Oh,
Russia.
Russia produces 40% of the world's palladium. Is that correct?
That's right.
And it's a metal used in catalytic converters and semiconductor production.
And so we rely upon both the Ukraine and Russia for some key things that come into play for semiconductors and for cable sets. And so there's two whys, W-H-Y, why. Why does the war affect, why is, people are saying they're blaming this on the war. Is that real? Yes, it's real, because we do rely upon those two countries. It's a big export. 40% of the world's palladium, and palladium is a key ingredient to semiconductor production. Neon gas is a key ingredient to making cable sets and the insulation and things of that nature. And so, yes, we are being affected. Not just the U.S., but the whole globe is being affected by the war in Ukraine.
Yeah, and Ford and GM have announced some production halts. What have you heard about other companies like Toyota?
Toyota actually, as of the date of this recording, has begun actually doing strategic production line shutdowns. And so they're kind of best I can tell, a rolling shutdown.
Oh.
I read an article about this. So that began soon after the Memorial Day holiday.
Okay.
And continues to go. So and that's because they can't get parts. They have not got the raw materials.
Yeah.
And so they're having to be very careful in doing it. It's kind of doing a dance because they don't want to send everybody home at once, because they got to keep making production, but also they do not want to lose their labor.
Yeah, because that would be scary in itself, to be able to try to have to replace all the people that, if they were laid off, to replace them all when there's labor shortages to begin with.
Right. And so the whole planet is having to do a dance. Mm-hmm. Everybody at every level, almost every link in the supply chain is having to do a dance, because we talked about in previous podcasts, if we're dealing with just one thing, then there's an economic playbook move for that, mm-hmm. right? Mm-hmm. It's just when to use a football analogy, I know you're a football gal. If your pass game's not working and your run game's not working,
well, you got to rely on your punters and your defense.
Yeah. It makes for a hard, the punt game, the special teams better be solid and the defense better be holding the line. Because otherwise, go home, I guess. Mercy rule. I don't know, because it's not going to be a good day. Well, our industry is dealing with more than just one thing. We've got price increases and record inflation here in the U.S. So economic playbook will lay some people off. We don't have the people to lay off because we're also dealing with a labor shortage, so you can't do that. Well, we'll automate. Well, it's a raw material situation, so even if we spend the money on automating, the ROI on that automation now, skims off into the universe, because if you don't have raw materials, robots can't make raw materials either. So whether it's people or whether it's robots, if you're lacking the raw materials, you're still not running. Mm-hmm. And yes, it's true that a robot doesn't eat as much as a person. You don't have to deal with benefits and things of that nature. But still, a robot sitting still is not capitalizing on a return on investment. Mm-hmm. And so the return on investment begins to skew, because we spent this money, but we're still not running. Mm-hmm. It's like buying a piece of equipment and then it just sits in the corner.
And you might use it once a month or something.
Yeah, it just doesn't the ROI begins to fall down.
Yeah.
And so
so these issues aren't going away anytime soon, hopefully sooner than later.
Well, there were some predictions last year that we were hoping
by this time this year.
Yeah, mid 2022, which is, hey, welcome to mid 2022, mm-hmm. or by the end of 2022. Now, there are some that are still holding out hope that we will begin to see a recovery, a start of a recovery, a beginning of something that looks like and kind of smells like something that we remember to be a recovery.
Okay.
I don't think it's going to be a sharp recovery, but there are those that say, because that's the other thing that happens. If we're talking about recovery in Q4, what else happens in the United States and most of the planet in Q4?
A holiday.
It's holiday season, National Goof Off Months, as I've always called them. So November, December in the U.S., because we have Thanksgiving followed up by Christmas and New Year's Eve. So all these major holidays, and it's also the end of the calendar year, which means you better use your vacation up because you might lose it. So everybody's trying to use their vacations and trying to do that kind of stuff. And manufacturers are absolutely going to have to give people their vacations, or guess what? They'll quit.
You know it.
And we got this labor shortage. So see, there's all this stuff going on. We're having to do this dance.
It's a balancing act, isn't it?
So I feel like that while there may be a supply recovery, we're not really going to feel that until probably Q1 of 2023. So January, February, March of 2023 could be interesting if stuff's starting to come back. Now, the question is who comes back first?
Yeah.
And that is a whole nother podcast.
Yeah, it would be.
But and it's totally crystal ball at this point.
Yeah.
Because even with a lot of companies I've heard of a lot of companies with a lot of great and solid strategies, but, again, strategies, just like ROI on an automated work cell, is still tied to certain things, certain variables, and raw materials is certainly one of those. Mm-hmm. So if you can't get the parts, if you can't get the stuff to make the stuff that you make, then you're out of luck. And so that's where everybody's kind of scratching their head.
Yeah. So what are some practical automation alternatives that you've...
Okay, so the title, or what I said, was practical automation alternatives that may not be obvious. Mm-hmm. And so what do I mean by that? So an obvious thing is, and we've been seeing this for months, I can't get that sensor. I have a specification in the plant for a specific name brand of sensor, this part number, that kind of thing. And you can't get it. It's long lead time or something's going on. It's got a chip in it. We can't get it. So sensor, servo drive, motion control type system, PLC, HMI, all those kind of things, robots, those kind of stuff. So you have this deal. So let's just use a sensor as an example. So I have this sensor. I can't get that brand, that part number of sensor. So the first thing, the most obvious thing is, okay, within that manufacturer, what other sensors do you have that are similar to this sensor from the same manufacturer? And what people are finding is, nope, it's all of the sensors. There's no equivalent within this manufacturing brand. And so the next most obvious step is, okay, let's look at different manufacturers for that sensor. Uh-huh. And so suddenly you start reaching out to these other manufacturers. And honestly, that's where we are right now. Companies are just like, what do you have? Mm-hmm. What can you get for me? And so we, even here at elliTek, have been spending really the last 6 months. I joke with folks and say, for the last 6 to 8 months, our salespeople have been acting more as grief counselors than salespeople. Yeah. Because they just can't make it happen. They just can't produce one. And so it's more like, I know you've been waiting. I know you need this. I know you're down. Can I get you a cup of coffee? Maybe a Starbucks, something venti lotto, something. Lotto. You can tell I'm a coffee drinker. I am not a coffee drinker, by the way. And so, but we're just kind of trying to, we understand at the same time we're having to be, counseled by our vendors and our suppliers because they're having to do the same thing. And so it's a shared kind of deal. We all are going to have to have
pain, isn't it?
We're going to have a global semiconductor shortage supply chain crisis support group.
That's a long title, but we could make up an acronym.
It's going to be some kind of an acronym. You got enough letters, you can spell something. But it's just really been, and I'm of course being humorous here, but it's really a big problem. And so the most obvious things are just, okay, what do you have? Just change manufacturer, but give me the same thing. And so what if that's not working? Because guys, it's not. Everybody is out. Everybody's out of whatever you need, probably. Now, sometimes we can find stuff, and we even have been dealing with, we are still jumping through hoops with some of the lines that we have, especially servo motors, drives, linear motors, things of that nature, where we're finding things for people, finding ways to substitute. But some of the interesting stuff that I've seen is when you do the most non-obvious thing. So as an example, instead of, so we had a situation where the customer had a system where the whole design was based around what's called a 3-axis pick and place system. And so that's just an X, a Y, and a Z. So we call that a Cartesian robot, but X, Y, and Z. And the Z has something on the end, a gripper, a suction cup, something, and they're moving parts with it. Well, the motors and drives, servos, all that kind of stuff, we can't get, even going outside of the manufacturers. The PLCs that we need to control that and all that kind of stuff can't get. You know, the HMIs that we need we can't get them, no matter whose brand we're looking at.
Yeah.
And so you finally reach a point of really desperation just to say, you know, what do we got to do here? Just give up. We really need this. We need to automate this process. And so if you're just giving up, you're kind of giving up because you're sticking with the most obvious alternative. So what did we end up doing there? Well, we came in, our engineers talked to them and said, and our salespeople were spot on. They were, checking out what's going on. And they said, you know what? For about the same amount of money, we can put one of our Hanwha 3-axis, 3 kilogram, 6-axis, but 3 kilogram collaborative robots in place of that pick and place.
Oh, okay.
Because it wasn't a high-speed pick and place. And we were guarding it because it was going to be guarded anyway, or the user was going to guard it. And so we can, again, with Hanwha, what we like about it is we can not completely disable, but mostly disable, increase the torques and the forces and the speeds and everything like that. And we can get better speeds out of a collaborative robot, which means we still have direct teach, but it begins to start becoming more of an industrial robot, not a collaborative from a safety standpoint. Again, it's guarded, so that's fine. But we have those in stock. And so suddenly, for about the same price point, usually when we're talking Cartesian systems, just as a budgetary to cover the controller, the motor, the drive, the cables, and the actuator, usually you're probably, to be safe, $6,000 per axis. So a 3-axis system is about $18,000. And then if you have the setups with the transition plates, all the mechanical stuff to put it all together and mounting stuff, and then of course the wire management and all that kind of stuff, you get up around $25,000. And that's a budgetary number, okay? That's pretty much a universal thing. That's just a way that I always calculate stuff. Now, today, with surcharges and stuff like that number is probably a little bit farther north. But on average, probably 20 to 25,000 is what we're looking like. Well, the 3-axis Hanwha robot is right in that price point.
Oh, wow.
It has the controller already. It can stand alone. We don't have to have the PLC for it to work. It's got its own controller. We don't have to have the HMI. We can use the teach pendant, stuff like that.
Okay.
And so now all of a sudden we're considering something and they're like, hey, let's move forward with this. But if we'd stayed with the obvious, which is replace a motor with a motor, even if you think you're thinking outside of the box to say we're going to go from one manufacturer to a different manufacturer, but it's still a motor and it's still going to be in a Cartesian system. The most non-obvious thing is to start thinking, well, let's get out of the Cartesian robots and start looking at an articulated arm robot.
So are there benefits of putting a Hanwha on there rather than a Cartesian?
Well, I think so. Of course, the direct teaching stuff that comes with the collaborative makes it easier to program. But also, the fact is the system that was picking up parts was placing it into another nest that then had to have it was pneumatic, wasn't electric, was going to have to do some rotations to orient the part and apply it for marking. And so there was I think a spray printer. I think it's a printer. No, it was around a printer. It was putting a paint mark on it.
Okay.
And so they were going to have to orient the part and all this kind of stuff. So you had more complexity for mechanical systems. You stick an articulating arm robot in there, it comes down, picks up the part, it can rotate in 6 degrees of freedom. And so it just brings it over, presents it, does the paint mark, goes over, presents it to the vision system, all this kind of stuff. So now all of a sudden, it really simplified the design of the entire system. It's just that we've always used a Cartesian system here.
Yeah. We've got to get away from that. We've always done it this way.
But it makes, so let's go pre-COVID. Stick with the Cartesian system. It's always there. It's always worked. It's proven. If it's not broken, don't fix it.
Yeah.
Fast forward to 2022, when we're in a supply chain shortage, we're in a parts shortage, we're dealing with all this stuff. What do you got? What can you get me? Well, you got to start thinking outside of the box, not just what manufacturer do you sell and do they have inventory of this same thing that I need, but more so, let's look at it from a 30,000 foot view and an engineering standpoint. Push your engineers to start thinking outside of the box. You have to. And unfortunately, for all people, not just us engineers, it's difficult to think outside the box. You always need to gain a new perspective. Mm-hmm. And sometimes podcasts like Industrial Automation, it doesn't have to, provide those new perspectives. But in our case, we were sitting in a room kind of saying, well, what are we going to do? What are we going to do? And somebody's like, I guess we give up. And somebody said, what if we use a robot? Ding, all of the wheels start turning, and you start seeing benefits suddenly. And we kind of go from there. And the primary benefit is it's in stock. And so, we have them in stock here at elliTek, but we can also get them in 2 to 3 weeks from Hanwha. And so they're managing everything on their side perfectly. And that we've said that before.
Oh, they have a new cobot, don't they? Hanwha. They've
got a new model that they've rolled out.
Yeah.
It's a 14 kilogram model. It looks pretty slick.
It does, yeah.
It's actually got some. It natively supports Profinet, which is a European field bus.
If you don't know about field bus technology, scroll back a few episodes. I'll put a link in the show notes.
There you go. But that makes it, Profinet. Profinet is a field bus that was invented or created by Siemens. Ethernet IP is a field bus that was created by Rockwell Automation or Allen Bradley, same deal. And then those are probably, and then of course there's EtherCAT, which is a Ethernet-based field bus that was created by Beckhoff, I believe, is credited with that. And so everybody has their own flavors. With this new Hanwha, it's got Profinet on board, and so that Siemens is, of course, the global number one of all PLCs in the globe, and that's just, sorry, Allen Bradley, that's just a fact. In the U.S., Siemens is a number 2. Allen Bradley or Rockwell Automation is number 1 as far as market share in PLCs specifically. So everybody so in the United States, Ethernet IP is probably more common than Profinet and EtherCAT, but they're coming. Mm-hmm. So as we in the U.S. become more and more privy to the advantages of other field bus protocols, Siemens is a solid number 2, and then of course you go everybody else. But if you look at it from a global standpoint, Siemens is absolutely the big kahuna. Now, if you're in Asia, it's not Siemens. It's not Allen Bradley. It's going to be, I don't know, Omron, Mitsubishi, one of those two probably are fighting for number 1 in Asia. So it does come down to where you're coming. But on average, across the globe, Siemens is number 1. And so I think that's why Hanwha picked natively support Profinet. Now, they can support other ones, but that's the one it comes with.
Okay.
I believe. And of course, it's a brand new model, so I'm still learning too.
Yes.
It's not been officially released in the U.S. yet, but they've rolled it out in some shows over in Europe and also in Asia. It looks sweet.
It does. It does.
So it's a higher payload and longer reach, and of course, it's built industrially. Mm-hmm. So anyway, we're talking about the non-obvious, and so substituting, as an example, a Hanwha robot, a collaborative robot, for a pick and place is an example of how we at elliTek actually did do that. And it's not the most obvious choice to replace a Cartesian with a robot. Mm-hmm.
Do you have any other examples?
Well, so the other thing that I've seen is, and this is kind of a 2-part deal. So if you're C-level, production manager, business unit manager, or plant president, you're looking for cost savings. You always are looking for cost savings. If you're not looking for cost savings, you need to find a different job. Cost savings is what we want. Always, we want to try to save cost. And that's just the nature of production, any manufacturing. And so one of the ways to decrease cost that's always been around is to reduce your spare parts inventory. And so a lot of people are choosing for a couple of reasons.
Okay.
They're saying, we can't get the motor because it's a long lead time. So we're going to pull one out of our spare parts inventory and use it on this new project or send it to the machine builder, the systems integrator, whatever, this component to use out of our spare parts inventory. Makes perfect sense. Been doing that since time began, probably. Uh-huh. And so it's not a big deal. But right now, it can be a big deal. So it was a dual benefit before. We have 2 of these motors in spare parts. We don't think we need 2 of these motors, so we're going to yank one of them and send them to the machine builder and gets them going because it's a long lead item, and it reduces our spare parts inventory by 50%. Hooray. We just saved money and saved time. That's always a win. However, if that component has a 30-week,
you could
40-week, 50, remember there's 52 weeks in a year, folks, if you need help with the conversion, but there's a plenty of people out there giving 52-week lead times right now.
Wow.
And some more. Be careful, because what you're giving away to save time and also is saving, perceived spare parts cost. You may be giving away solid gold.
Yeah.
So, you have to do a risk analysis there, just like anything else. We've had 2 of these things in our spare parts inventory for 10 years, and we've never had the process go down, probably safe. But if you have 2 in there and you have 2 or 3 of these machines or more, what are the chances that 2 of them may need motors at the same time? Because if you do, and you've already spent one of the motors and now you use up the other one and one more dies, the downtime of, again, even 30 days of downtime, but 30, 60, 90 days, then we start jumping up into
a year?
Yeah, months and a year. I don't know how you ever make back that cost. And so just as a word to the wise, your spare parts inventory is highly valuable now. I mean, guys, if anybody has, unless you've been sleeping under a rock, used cars are extremely valuable. Your spare parts inventory with automation equipment right now, especially anything with a semiconductor in it, with a chip, is worth a lot. And so be careful about going ahead and depleting your spare parts inventory without really thinking about it. Because remember, now I've talked to a few spare parts managers that are saying, well, we've got to, as soon as I pull one out, it kicks the reorder point, and so we start that waiting game at that point. We are taking a little bit of a chance, but we've looked it over, and we don't perceive it to be a huge chance. If it's replaced in the next 6 months, 3 months, whatever, we feel like we can deal with that. Perfect. You've done your homework. You've done your analysis. But don't just yank it out and be kind of short-sighted to say the goal is to get the machine builder or get the equipment, the new piece of equipment going without doing that risk analysis. And unfortunately, you may have to anyway, even if it's risky. Sometimes you got to take a risk.
Yeah.
But just remember, automation products are worth a lot right now, a lot more than they normally would be, and certainly a lot more than the price tag, because the cost, might not be immediately obvious.
Yeah, yeah.
And that's the other thing. You just cannot, unless you have it in your hand. What is it? A bird in the hand's worth more than 2 in the bush.
Yes.
Yeah. So unless somebody says, I have this part, I have this inventory that I can sell to you and provide to you. If it's an estimated ship date right now, things are so crazy. It's estimated. And while our vendors and other vendors are doing the absolute best that they can do, sometimes they miss it.
Yeah. I mean, stuff happens.
And a lot of stuff is happening. Let me tell you. So that's kind of the thing. So the 2 things I wanted to share is the non-obvious thing of don't just substitute part for part. Even if you're being a little bit, thinking outside the box to say, I'm going to do this part for this manufacturer and swap it for a different manufacturer for the same type of part. It may work, but it may not.
Well, when they switch to a different manufacturer, do you have to supply that
As a
additional
spare
part as well? Or
sometimes you do. Yeah, I mean, it's according to what you're talking about. If we're talking about a photoprox, probably not. An inductive proximity sensor, something like that, probably not. But if you're talking about servo motors and drives and VFDs and HMIs, yeah, you probably do. In fact, you're going to have to start looking at software and all that kind of stuff.
Like training.
And training.
Yeah, yeah.
So it's not an easy thing to. I mean, even though it might be obvious, it's out of necessity. It has to be out of necessity.
Yeah.
to change a standard. There's got to be a huge necessity. And maybe that necessity is there's benefits to this we couldn't see in the past. I mean, that's traditional reasons why companies change specifications, whether there's support that they didn't have with the other company, or there's some kind of function or capability that they were missing, but they can get it if they switch to this.
Yeah.
And so now you begin to digest all the things, the trainings, the software, the spare parts inventory, that all comes into play. It's actually part of an ROI, should be part of an ROI calculation.
Yeah.
But in today's time, it's just the necessity is I've got to get this to work.
Yeah.
We've got to do this process. We got to make this process work in a certain way. And that comes down to, why are you automating?
Oh, the 4 reasons, Brandon's Brandology for the 4 reasons to automate.
Brandology.
Yes. Oh, am I supposed to tell him?
Oh, you want me to tell them?
Yeah, because I can't see him. Wait. I'll try to remember.
Okay.
Okay. Quality, consistency.
Yes.
Reclassification of labor.
Yep.
Increase production.
Yep.
Decrease downtime.
Decrease cycle time.
Oh, okay.
And one more.
Doggone it.
Yeah, you won't get this one. It's always the one I forget.
Oh, flexibility, quick setup.
I'll give you credit. All right, so
I cheated.
flexibility, quick setup is the other one. So quality, consistency. So you're doing something that a robot can do more consistently or with more quality. Decrease in cycle time or increase in production, so you get more parts through for various reasons. Reclassification of labor, meaning we just don't have the people. Nowadays, we don't have the people to do it. Or flexibility, quick setup, meaning that if we automate the thing, it can switch between making this part to that part to this part quicker than having to change out stuff that, fixturing and things that human beings would require for the quality consistency. And so those are really the 4 reasons to automate. But despite that, if you can't get the stuff, those don't matter. I mean, those
That's
are great
true.
goals to have.
They are.
But if you can't get the stuff to automate with, then you're in trouble. So be careful about the spare parts inventory. Hang on to it. Manage it well. Mm-hmm. And
do your risk analysis, or
yeah.
do you do a risk assessment or analysis? Is there a difference?
Probably.
Okay.
According to how smart you are, I guess. But just calculate the risk, and then start thinking about even a different perspective of even more outside of the box than the obvious thing of replacing a motor for a motor, a sensor for a sensor, things of that nature.
Yep. Sounds good.
So that's our advice for today. So hopefully that perspective gets the wheels turning, and that'll help some folks.
I hope so.
So thank you, Beth.
Well, Brandon, you always bring a brand new perspective, a Brandspective.
Brandspective. It's that one. Brandspective. Thank you for all the research.
Oh, my pleasure. I get to learn something new.
In industrial automation, it doesn't have to be obvious.
Yes.
Guys, have a great couple of weeks, and we'll see you again in a month, I guess.
Sounds good. See you guys. Thank you.
See ya. Thanks, Beth.
Thank you, Brandon.
Hey guys, thanks for checking out today's episode of Industrial Automation It Doesn't Have To. I hope you enjoyed it. If so, make sure you give us a rating that's pretty doggone high, and do that everywhere you listen, including Spotify and Apple Podcasts. We'd really appreciate it. Also, don't forget about our website. That's www.ellitek.com. That's ELLITEK.com. If you want to reach out to us there, you can fill out our contact form. We'd appreciate it. Also, you can email us at info@ellitek.com. And certainly for those of you that still like to dial the phone, give us a call, 865-409-1555. We'd love to hear from you.